Section 4.4, Day 4. This is considered a review day for the prior 3 days of parallel and perpendicular lines. There is no essential question for this lesson. If you're taking notes on this lesson right now, I would just make a notes column and a question column, and then you can put 4.4, Day 4 review at the top, but you don't need an essential question. I would make this chart in your notes if you're taking notes on this lesson. We're going to be given a bunch of lines, and we're going to figure out what the parallel slope to this line would be and the perpendicular slope. So in my original equation, y equals 3x plus 1. The slope of this line is 3. So that means the line parallel to it would have a slope of 3. The line perpendicular to it, well, if I wrote 3 as a fraction, it'd be 3 over 1. So if I flip it and take the reciprocal, and I change it so the sign is the opposite, I'd end up with negative 1/3. In the second example, y equals 2/3 x minus 4, my slope is 2/3. So the line parallel to it would have a slope of 2/3. The line perpendicular to it, if I have 2/3, I'm going to take the reciprocal and have the sign be the opposite of the original. The original is positive, so my new slope is negative. Y equals negative 5x minus 7, the slope is negative 5. So the line parallel to it has a slope of negative 5. Negative 5 over 1, if I flip and change it, would become 1 over 5. Flipped it around, I took the reciprocal, and I changed the sign from negative to positive. Y equals negative 3/4 x plus 2. Parallel line would have a slope of negative 3/4. The perpendicular line would have a slope of 4/3. Y equals x minus 10. This one is always tricky. If there isn't a number in front of our x, look at all the other examples, we had a number in front of the x, which was our slope. If there isn't a number, then it's always 1. So the slope of this line is 1. So the line parallel to it would have a slope of 1. If I have 1 over 1 and I do the reciprocal, it's still 1 over 1, but I'd have to make it negative. So negative 1 would be the slope for the line perpendicular to that one. If I've got negative x, it's similar to the last one where I can put a 1 in there, except instead of being positive this time it's negative 1. So a line parallel to it would also have a slope of negative 1. A line perpendicular to it would have a slope of positive 1. Y equals 4x minus 5, my slope is 4. A line parallel to it would have a slope of 4. A line perpendicular to it would have a slope of negative 1/4. Find the slope of each of these lines. So we're going to be given 6 different equations here. Some of them are in slope-intercept form, some of them are not. You need to keep in mind that we only know the slope of a line if it's in slope-intercept form. So that's the first question we're going to ask ourselves on each of these problems. So let's look at the first one, y equals 3x minus 1. This equation is in slope-intercept form, so I already know the slope. This one is easy. It would be positive 3. The next one below it, y equals negative 2x plus 5. It's in slope-intercept form, so I immediately know the slope. It's negative 2. The third one is not in slope-intercept form. This one is in standard form. So that means I need to get it in slope-intercept form in order to know the slope. I'm going to start by subtracting 2x on both sides. My goal in the end is to get y alone. I always put the negative 2x first, then bring the 12 down after. The 12 is positive, so I put a plus in front of it. Divide by 6. And then here is where we're going to do our heart. I'm running out of space here, so I'm going to move right over here. Y equals negative 2 over 6 can be simplified to negative 1/3. 12 divided by 6 is positive 2. Now my equation is in slope-intercept form. The slope is negative 1/3, so that would be the answer. The slope of this equation would be negative 1/3. 5y equals 2x plus 10. I'm going to move that one up to give us a little bit more space because it is not in slope-intercept form because that y is not alone. I have to divide by 5 in order to get the y alone. Y equals, I do my heart, 2/5 cannot be simplified, so I'll leave it as 2/5. 10 over 5 gives me 2. The slope in this line is 2/5, so my answer is 2/5. This equation, y equals 2/3 x minus 4, is already in slope-intercept form, so my slope is 2/3. And this final one is not in slope-intercept form, so I need to get it in that form. Train tracks, minus 4x on both sides. Go off the screen for a second here. Minus 4x. 2y equals, I always do the negative 4x first, 8 is positive. Divide by 2. I do my heart. Negative 4 divided by 2 is negative 2. 8 divided by 2 is 4. So the slope of this equation is negative 2. Write an equation for a line that is parallel to each of these lines. So they're not giving me a whole lot of information here except for my given line. Now in the examples we did in the other lessons, they gave us a point that our line needed to go through in order to figure out our y-intercept. On this one, our y-intercept isn't going to matter. We can make it be whatever we want to. The important part is going to be our slope. So let's look at this first example. Y equals 3x minus 1. My slope is 3, so that means a line parallel to it has to have the same slope. So my slope also has to be 3. I can choose any y-intercept I want to, because if you think about it, if two lines are parallel to each other, their slopes are the same, their y-intercepts are different. The only y-intercept I don't want to have is negative 1, because that would mean both of my lines are exactly the same. They make the same line. I have to have a different y-intercept if I want parallel lines. So I'm just going to make up plus 2. For y equals negative 2x plus 5, my slope is negative 2, so my line parallel to it has to have a slope of negative 2. And I can make up any y-intercept I want to, but it can't be plus 5. I'll say it's minus 3. And for the third one, y equals 2/3 x minus 4, my slope is 2/3. So that means the line parallel to it has to have a slope of 2/3. And I can pick any y-intercept, it just can't be negative 4. Let's pick 0. Now we're going to write an equation for a line that is perpendicular to each of these lines. So we know if lines are going to be perpendicular, the slopes have to be flipped and changed. So if my slope for this equation is 3, the flip and change would be negative 1/3. Now I also can't have a y-intercept of negative 1, although let's see if that's true. If I graph this quickly, my original line has a y-intercept of negative 1, and then I rise 3, run 1. Let's see if we could have a minus 1 there. So my new line, I have a y-intercept of negative 1. If I rise negative 1, run 3. Does it work for perpendicular lines to have the same y-intercept? Yes, it does. They could have a different y-intercept, but they can just have the same one. So we'll just have them all be the same to make things a little bit easier. So let's look at the second one. Y equals negative 2x plus 5. If I flip and change -2, I'd have 1/2, and then we'll put the +5. And then if I flip and change 2/3, it'd be -3/2. The homework for this lesson is a review worksheet.